let's get right down to it. We're going to spin this. We're going to spin this the other way. That was a little hard. I didn't mean to spin it that hard. We don't need to do all that. It's going to go regardless. Because the reed switches I have in this thing require like less than a volt to operate. They have a decent operating range. But the minimal optimal, well, depends on what you consider to be optimal. I think less than a volt is pretty optimal. Allowing this to remain pretty much, countercoupled. That's what I like to call it. It's easily distinguishable then. When it's coupled, it's both going in the same direction. When it's countercoupled, they're magnetically coupled, but they're going in opposite directions. So I've been doing this kind of once or twice. In the morning, and then take a break, and then you do it again. But here, look, this is the big change that I made. Where did it go? Well, here's this one of these. This is basically a bridge rectifier, okay? This big honking thing right here is a bridge rectifier with a filtration. It's got DC caps on one side, AC on the other. It smooths it all out, makes it nice and smooth and everything. Probably uses up half the energy you put into it, So I got one of the bridge rectifiers, one of the normal ones, full bridge, that I play with. I got the spade caps on there, and I've got the wires going to where I need to go, and this is running like it's running right through it, like straight from the pickup to here. It's like there's so much more energy, it looks like, getting to where it needs to be, which is into the wire and through the reed switch and then back to the bridge rectifier. Now, because of how hard I spun the stator, it's probably going to go for longer. The rotor's going to stop first. Because it is going to dip down below that point. Because the pickup coils are 1.5 inches away from the magnets, and I did it that way to mitigate lens effect. There's like literally nothing happening with lens right here, but there's definitely generation going on, which means I kind of hit a nice spot for that to be possible. You can't really move it too much farther out, or you're going to get nothing, or nothing that you can use with even this reed switch. And if you move it too much closer, you're going to get a lot of lens. You might get more energy, but it's going to stop. It's going to stop, and then it doesn't mean anything. So I mean, if you can keep it going, I'm not sure exactly. I have to time it yet. But I got this one. Wait a minute, no, not this one. It was the solid one, not on a rotor, the permanent magnet array that I had attached to the pole, and it was solid. I spun the stator for like 16 minutes and 42 seconds with all that magnetism in there, and it was like, well, that's pretty cool. All right, it stopped. Probably stopped a little while ago. I can see the stator still going, like hardcore. But here, let me I'm just gonna hold this. I'm gonna see if there's any vibration coming through here from like the reed switch connecting and making an EMF, electromotive force. I think that's getting faster. Does it look like the stator's picking up speed? I don't know. Looked like it. I think it looked like it for a little bit. Hello, hello. Sorry, I got hello. I was enthralled, man. I'm this is crazy. Technically, it shouldn't be able to do this, but I think the distance, the proximity from the coils and the magnet is right. It's right for it to happen. So I'm doing a nice spin like that now. I'll leave that as it is. Now I was talking this over, and like if I got the conditions right and everything was well balanced and everything else, man, I could probably get it to go for an hour. But then also to get it to go any more than that, I'd have to get it into a vacuum chamber, which means I would have to change the design completely, which, you know, I could do that. I'm not too attached to this. I'm not like, you know, like it has to be this way. I was gonna make it like a saucer. I was gonna cut off the tail end of this thing and just have it be flat. That would have been cool. And if I have it spin too, yeah, that would be awesome. And then maybe make the coils. They got to be a little smaller for me to make the rotor smaller. I'm not sure that's the answer though. Making everything smaller, I'm not sure that's the answer. I think you might need to add some more weight to it, and it'll lower it down a little bit more because it's magleved in there. And there's maybe about a centimeter and a half, 2 centimeters there to play with. And you don't want to put too much on, but you want to get it down a little more. You want to get it down about a centimeter, maybe, you know, 0.75. So that it interacts with the magnets more than it's doing right now. But it is good right now. It is pretty freaking good, actually. It's a little above halfway. And if we know about the permanent magnets, the strongest field is on the edge there. So it might be good. I don't know. I think it's moving great. Is it slowing down? Yeah, every turn. Every time it turns, it's slowing down a little bit. But I've tested it without all this jamboree, and I believe it goes a lot like farther. And honestly, I'm going to say that because all this stuff does create a drag on it. And with that being said, the fact that it's going like how it's going means that there's definitely something happening. But that something is what's slowing it down. Absolutely. There is definitely a lens kind of effect going on that will slow it down, stop it faster than if these magnets weren't there. I can feel it jerking these things, man. Like something is definitely when I'm pulling it. All right, so the rundown here is that all these stator magnets are facing north to the center. Because I think I rolled all these coils counterclockwise. So I think having the repel action going on is going to be awesome for this. And then and then I've been running with south, but then I realized that, oh yeah, I rolled them a different way. So no, I've decided that, wow. I don't know. Maybe the coils underneath are heavy. Maybe they're a lot heavier than I remember them being. I don't know. That could be something too. Just want to gently spin it, nothing too major. Get them going. I know that, like, with the setup that I've had, I've experimented the hell out of it, and it's like I'm gonna change up the coils, the pickup coils. I'm gonna go to 32, and I'm gonna make them in series. I'm gonna see if I can't get a little bit more energy out of them without creating a huge lens effect. So I'm gonna start by changing one coil. They're 30 gauge in there right now. But if you move them up front, it's game over. It'll create a braking effect, and then you lose. Now I don't know, man. That's what happened the last like 4 or 5 times I tried doing that, and I think that maybe these diodes that I had administered the last time I decided to try it again. So I added 2 rectifier diodes on this before it gets to the bridge rectifier. Why? I wanted the direction to be obvious. So I did that, and yeah, I don't know, man. I think it's going really, really good right now for like what I know I did, and what's going on right now. Something is definitely taking that momentum and multiplying it by either a multiplicative factor or an additive factor. So but I think it's just increasing, not the power. Oh man. The momentum. And that is the power. That is the power source. The momentum from my hand is what's making all this stuff move right now. But it's moving for quite a while. Like, there's no way. And I keep saying this, man. I know what I did. I know how I pushed that thing, and there's like no way without aid that it would be going as fast as it is right now. Now with all that stuff in there, no way. But it's proximity. So it's just the very edge. I spun it, and I've like tried to clip the multimeter to get how much voltage is going through it when I spin the stator. I got 3 volts one time, but that was with my 4 banger. This is 120 right here. So I got 3 volts with that, and I get 1.5 to 1 volt with this, spinning it really fast. That's how I know that, like, if I had a huge reed switch in there, it wouldn't work at all. It wouldn't work at all. This takes a little bit of energy and it turns it into a lot of you know, what it's going to do. They're the smallest 3 switches I could find with the gold plate. So oh yeah, I was gonna show you guys that like right now, actually. And this is gonna be interesting because I'd never put the magnetic rotor in there with 3 opposing sides and 1 repelling side. I don't think I want to do that either. So I'm gonna do this. This way I don't have to change up the rotor. It's good for me. Here, we'll start on the top. Now this is a permanent magnet rotor. This is a permanent magnet stator. This should not take a second. Here we go. Oh, nope, that's not going to work. That'll work, I think. I might have to take this magnet off the bottom here. That's moving really, really well. That's awesome. Now that's going to get me 25 seconds maybe. That's where we're going to start. Now we're going to drop it a little bit. That's counter spin, that's counter rotation right there. Now I'm going to go couple spin. Well, I'm going to let it simmer down. All right, I think I'm going to get some more magnets. I got them right here somewhere. Here it is. And I'm going to put 3 of these Neos on the north. Because that's the one that's actually spinning it. We'll see what happens. It's probably going to crash. I'm going to stop it. There it is. Okay. You know what? I'm going to do them one at a time because wow. Oh, wow, dude. Yeah, it like stops it right here at this point. I don't even know how much more of this I can put on before these magnets are just gonna suck them right off. That's gonna be a sight, man. You're gonna see some sparks. Wow. Okay. Now they're coupled like strongly through attraction. But that's still a counter spin. That's awesome. Yeah, I don't know, man. This is like 100% mine, like me. Like, I don't know. I don't know anybody who's doing this really. There's other things kind of like it, and it's just utilizing a lot of like simple concepts like a maglev, a magnetic repulsion and attraction. That's it, really. Now, what I think I'm going to do is I'm going to get a 6 magnet rotor for the middle to go with the 6 magnet on the outside. So when we go in couple mode, it won't do that. Now this is 3 to 1. And see, I stopped the rotor in the middle and everything stops because this is way too much. There we go. See, I'm glad I'm on top of my game right now, man. that would have hurt. All right. So you remove the just two magnets, man, and then everything gets back to a smoother rate. Now, I want to get... See, I like the idea of the rotor and its ability to spin in the middle, but with this current setup, I don't think... I think there's too much space here without a magnet in it to make it do all that fancy stuff. So what I'm saying is, honestly, gonna need like 12 magnets on the outside here. And getting those magnets in is gonna be a real trick considering how strong these are. You know what I'm saying? And I'm not saying it won't be done. I'm not saying I can't do it. I've done crazier things than that. But yeah, this is the rotor, and it spins. Now I have like a stator set that's very still, and it doesn't move. It tries not to move. for the other side of the coin, where having everything be still is advantageous and better for the overall effect. I got two things. Well, only one of these is going to be still. And for this one, all right, let me grab the magnets. Yeah, that's great. That's cool. Yeah, no, the gravitron. I know what you're saying. Taking the force and pushing everything to the outer edge and up. So it kind of goes like this. On the gravitron, though. I mean, this is anti-gravity is a way different thing than that. But that's what this is. Looks like to me, you know. See, I need little, like, smaller ones of these discs. And maybe even Neos. Make them Neos. Then I can put this on top of that. So you have a solid one and a rotating one. All right. Let's see here. Yeah, I can barely feel that. I need to get more magnets on there. I don't have them right now. Anyway, that's the idea. You got the one that can move, and you got the one that just kind of stays there. And that stator, the outer stator, is what we're measuring. But I think those were a little, they're nice wide field, but they're a little too far away to be only them. I need more. Now see, I got this 5 magnet rotor down here, and it's actually, it would fit right in there, but I'm telling you, it wouldn't move an inch. I mean, counter spin are separate up from each other, because even though it's 5 and they won't line up, it's a very strong field on both things. You know what? I'm going to do, let me get 2 more of these. See, like this, these ones are like right next to each other. This makes a good rotor. But I don't have a 1/4 inch setup anymore. I don't have any 1/4 inch table anymore. This is the only 1/4 inch I have right here. So maybe when I'm done here, I'll put it back together. Okay, so we're going to add 1 to each. Wait a minute. Oh, do we want to go north in? Oh yeah, no. I don't know. Because if we turn these around and have them go north in, then there's going to be 1 repulsion and 3 attraction. I don't think it's going anywhere with 3 attraction. But I don't know, honestly. So maybe, nah. All right, let's all get ready for. I don't even think I want to do that, but no. Here we go. Oh. Let's do that. Put the bearing in there so we don't have a slow. I wish I had more ferrite magnets, but I don't. I've got 2 more of these rectangles and 2 more of those big spheres, and that's it. Including the ones that I showed you. So I asked, how long is typically for this going to go? Like, what am I looking for? And she said between 10 and 30 seconds. So maybe we remove magnets. Yeah, sounds like a plan. All right. All right, I'm going to come over here real quick. Hold on a second. Any suggestions? No, man. 10, 30 seconds with this. I can make it go, but it's a different thing. It's not this. But I'm currently going through a charge. I don't have one hooked up right now, but I'm charging all of my batteries. Trying to get them to 13 plus. So I have my bearings correct on that. Yep. All right. So you got your maglev, you got your base of your rotor. And you got your 2 coils on each peg. There's 120 pegs on this one. And it's all done by a bridge rectifier. It's not powered. Like I said, I'm charging all my batteries. Something's not right with the shaft. I hate that. Maybe it's the bearings. I'm not sure, but they feel like they're like gunked up. I don't know what the dealio is. And then sometimes they're, oh, there it goes. Anyway, I had the shaft sticking up. Right now it's touching the table down here. Now when I spin the outer stator alone, this system generates about 1.1 volts at its max speed, at my max speed. Now over here on this radial setup, this style pulse motor using one of these, I can get one going pretty fast below a volt, less than a volt. So in my mind, that's functionality at its minimal point, but yes, definitely working. And the setup is very cheap because the drive coils are 20 and 28 gauge. They're bifilers. So they're hooked in series with themselves. And then they're hooked in series with each other. So making a very long strand of 20 and 28 gauge. So it's going to be 28 gauge current limited, which is real good for a thing like this. And then it's going to have more mass for the same length with the 20 gauge. Can't go wrong there, considering that's a drive. But I have them each hooked up individually with their own reed switch and their own rectifier. And they're all hooked up to the bridge rectifier, which is like the hub. It's where everything happens, where everything's connected. Now, is it designed? No, man, it's not designed to have a load on it. Okay, so no load. And I'll say that as many times as I need to. There's no load. And I don't know. I know that one. That one for sure. You can't put a load on this. To even like suggest to put a load on it is not my, it's not, that's not my mistake. Okay. I love how smooth it runs, man. I mean, that's awesome. Hey, what's up? I think a UFO is probably has a little bit more pieces than this, but no, it's more of a gyro. It's one aspect of a gyro. Another gyro would have more orbits, but this one's just got the one that goes both ways. Now, I am working on getting my batteries charged up and seeing which ones are duds and which ones aren't. I have to go through all of my stuff and throw away the stuff that doesn't work. I have to find a way to test my clips because something isn't right. Like when I try and put 3 drives into one area, I get a loud resonant squeak and it doesn't work right. And I'm trying to figure out what the problem is. I'm thinking it might be too much energy for this little tiny space, and those coils are probably interacting in a way that's allowing for that to happen. Man, but as soon as I get that third one on there, when I start it up, there's no stopping it. That's the problem. So I got one of these bad boys. That's an infrared trigger receiver, right? So that we're gonna do that nice and easy peasy. We're gonna do a flip-flop circuit. So when I turn it on, I can turn it on. When I turn it off, I can turn it off. I guess there's an additional flip-flop circuit that you gotta do. So my brother said he's gonna get me a present. And it's funny because it's his birthday coming up. Yeah, so it's his birthday and he's going to get me the flux imbued solder. Flux imbued solder. And I'm going to start training myself how to make, the circuits smaller, but like doing the flux and like not having a helping hand and all this other stuff making it really difficult to even begin to try, to learn how to do it. So I didn't have any of that, but I will the next time I go. See, but the thing is, if I had that bigger bridge rectifier, this is essentially a bridge rectifier. If I had this on here, I could hook a battery up to it right now. Just hook it into the AC side. And then it'll take that energy and push it right through like there's nothing. It says don't do that, but I'm like, hey, I do it all the time and my things still work. So why not? And that's, I guess, because if there's a surge or something, there might be a problem. But it's a 12-volt lithium battery. I haven't had any surges, but I guess it can happen. Yanni! There's my 12-volt battery packs that I use. And then yes, Yanni, for sure. Man, I want to talk to you about batteries. Not ones that I would use to run something like this that require less than a volt. Maybe Mike talk to you about that as well, if you're still around. Because that's all this thing really needs to work. Is like a volt and a half to run at peak performance. She said no copper. When I say she said, it's the robot. The robot said no copper. So I got aluminum wire and an aluminum rod, and then we make that insulator with the electrolyte. and we tie this together, that should give us a 1/2 volt, right? What if I make them cut it down to like a 3-inch stock? No, making the battery, manufacturing a battery. I can't put 50 volts on that reed switch. Oh man, have you seen it? It's like the smallest one you can buy. This is, I could just, you know what? I got plenty of awesome stuff planned for this thing. And I need to get my act together, get it all together. You're like, no, that is the watering hole. Yeah. Yeah, it would work really, really, really good on 3. It works good on 12, but you got to have resistor on it to use a 12-volt one with it. You know, like you got to put at least 100-volt, 100 ohm resistor on there. It's still like doing its thing, and I mean, you can definitely not say that this counts. This doesn't really count, but it is still counter rotating. That's pretty amazing to me. It's like jerking. Is that cogging? Is that what's going on right there? Nice. Heck yeah, man. I guess I'm just gonna make like this capacitor thing that with the aluminum and then the insulator with some electrolyte on it, and then wrap this up in this aluminum wire, and then maybe do another layer of paper, and then do some tin foil. That's cool, man. I'll definitely check that out because I'm looking for something, that'll last a while. Maybe recuperate itself somehow, or use this thing's energy to recoup itself. You know, and maybe there's got to be some sort of exponential gain happening in the cell, either through longevity or through capacitance. The voltage can be low. Voltage has to be low, actually. I don't want anything to get damaged, I got 3 of these 2-foot bars of aluminum, and I want to put them down into 3-inch bars, and then wrap them up like I told you, and put them on a disc that's about this 14-inch disc, and run them parallel. That would that would run it into next Tuesday, man. And then, like, instead of having that black plate on the top there, you have it be the power source. And of course, eddy currents will be predominant in here because it's going to be all aluminum. Because I guess the resistant conductors are way better for doing this type of electric work. electric work. Now I was gonna get this like cotton string and dip it into salt water and wrap it up. But all that stuff. You were talking about the diaper additives the last time you were talking about this that I was watching your show. We were talking about where you found the absorbent water lock, the moisture lock material, and maybe I'll use that. Who knows? Because I understand if you're using some sort of electrolyte that you would want to keep it moist. Yes, indeed. So it's these clips right here, these 3-to-1 clips that I use. They're really, really, really cool, man, because I get to take that one connection to the bridge rectifier and I get to make it two. And that's what I've done here. But you can do that with solder too. So solder is definitely going to be part of it coming up. Man, I wish I timed this so I could know exactly how much it goes. Because I had the south in there. Do you want to do it? Is it south now? Yes. All right. I think that the 3-banger with the transistor works really nice with the 6 magnets. It'll hit its 120 twice in rotation. Completely separate magnets. 2 times. Okay. I swear this thing runs better with the north facing in. All right. Almost. Because when I was rolling the coils, I believe that I rolled them counterclockwise. I know that the newest batch that I rolled counterclockwise. And the reason that I can definitely know is that we start at the top of the tick meter, basically. So, like, if you're rolling a coil that's 2,222 turns, you're going to start there and work your way down to 0 if you're rolling counterclockwise. on my machine. I'm not saying anything else other than that. That's how my machine works. And yeah, I like using my machine, especially to roll the 26 and 32 coils that I've been rolling. Those are really nice. They can run this with a transistor to a point where I don't have to watch it. It's like so smooth. Oh man, it's great. It never gets going too fast. So I'm gonna think I'm gonna build it like that. But I'm gonna make, now that I've got everything taken apart, and I'm gonna make probably a 6 coil rotor. It's gonna have 12 coils on it. No, 7 or 9. That one, we can do that. So 40 degrees. Probably do 9. And we'll have 12 on the outer stator. Or even 10 on the outer stator. We're not trying to make it impossible to put the magnets in this thing. We're trying to make it so that there's a very strong ring of a magnetic field. Now the reed switch is going to work pretty much no matter what. You see it now. Look at it now. That's amazing. So it has to, like 5 magnets have to pass before, it'll do it. And I'm trying to change that. I'm going to make it into 32 gauge coils. Heck yeah. Here, like, I need to get more ceramics. I got the ceramic rectangles for this one. And I was like, yeah, those were working really good. Like gently glazing off the other magnets. I'm like, yeah. And I'm like, where are the rest of them? And they're just gone. I got to get more. I moved through like several moves with this stuff. We went from a storage unit to my mom's house to my house. And then I had to start rooting stuff out. I can't afford it. It has to progress. It has to progress. So I want to give a lot of my stuff away and be like, hey, listen, here, and I can make kits, and just have 5 jumper wires, directions, a transistor, like a bridge rectifier. You got your toggle switch, and you got your extension for your MPN or your PNP. You'll have the directions, so it'll be all right. But this makes it so you can connect more to your MPN, more to your PNP. Get some jumper wires in there, throw a battery in there. Like, bada boom. Now your variables are your coils and your rotor. Or I could sell a rotor too. Or rotor I can't give away. But like there's coils here that I've been testing that work out very well, and they're extremely well, and I don't know if I'm ever going to use them again. But I'm just trying not to throw the stuff away, you know what I'm saying? There's still some good stuff here. A lot of it is going to go in the trash. But like even more of it is like not going to go in the trash. I mean, that will definitely save a lot of what I'm working on. But I have run out of space. I have run out of space. And there's no money to open up any more space. But like that kit right there, I think that's a valuable, there's value there, you know. But I don't know if there's enough value there to make any money. I know that there's value there. You gotta do it smartly, but you can't do it the same as anybody else is doing it. You can't. Like, I mean, and your differences don't have to be humongous. They don't have to be like a night and day. It does not have to be like that. You know, it can be almost the same and not be a problem. All right. So last night I designed a 5 magnet cube rotor about this size. Don't know if I'm going to be able to put it together, but it's cool. It was cool. The pentagon, nice and balanced. And I was going to make it for the electromagnet, or no, the permanent magnet rotor. Now, if I were to put neo cubes in there, what orientation would you have me do it at? Like, would the cubes be axial flux? Or would it be Hallbeck array? Or would it be pole to pole? I mean, there's so many different ways you could do this. But what way is going to work the best? Because cubes on squares are really, really strong. And there's going to be, I don't even know if it'll work. But at least we'll have that 5 magnet speed demon of a rotor. We can then hook up an SSG. I got my SSG from kenergy.store. Some cool stuff down there, man. And I'm gonna break it out again, and we're gonna use it over here. We're gonna charge up our batteries. We're gonna, you know, just there's lots of things that I gotta, well, not lots of things, just a couple things that I gotta do. One of them involves getting my drop cloth out of the dust. All right, I got a couple things I want to show you guys. All right, just real quick now. What do you see when you look at that, man? That's a flower, right? But then there's a snake eating the flower. That's awesome. Or the flower's growing out of the snake's throat, but it look, you know. Jupiter. It's kind of what it reminds me of. But it's basically stretching the color without blending it completely. Got that. You got the rolling fog. I don't know. That could be like water. It could be sand. got your path maybe. And this could be some holy mountain. This could be, you know, the what's at the end of the journey. There could be a pot of gold back there. And of course, my initials are M.P.H. So in case you were wondering what the M.P.H is all about. This is the green sunset. It was referred to in one of the Pirates of the Caribbean movies, but it's actually legendary. Very legendary. And then you got your G6. That's a play on that. Boom. I have hundreds of these, man. I have lots and lots of paintings. Yeah, it doesn't, like, there's no torque to speak of. There's no power to speak of, actually. All right, let me spin her up. And I got a few things more to show you real quick. Just 3. And then I'll show you what my latest rotor. I think it'll work out. I gotta redo it, but I think it'll work out. It's an 8 pegged, but it only has room for 1 coil on each peg. So there's like some sort of flower. M.P.H down here. And I think like a poppy plant of some kind. It could be like one of those Asian flowers. I'm trying to remember what it's called. There's the green one. I like to call this guy the green one. And I'm gonna eventually get my my black lights. This is all black light. You can see what's going on here when I shine a black light on it. And this one is the same black light paint. And it's infinity related. Okay, so there's 2 symbols here. You got fertility, and you've got infinity. Infinity related. It's pretty simple. Really neat. I love doing that stuff. Thanks, Yanni. Yeah, I'm going to be doing that, when I'm not doing this. I got tons of supplies that I need to use yet, so. But I think 32 gauge instead of 30 gauge, and then having a little bit more of it is going to be, it's going to work better. I think the distance away is mitigating the lens right now to the point where there's only 1.2 volts of energy. And I think we can add a little bit more, we can create not create, sorry, we can generate a little bit more energy without having it stop. So I think we can get up to 3 volts. Matter of fact, I know we can get up to 3 volts because I've done it. Just spinning the stator. So when this starts counter rotating, when the rotor counter rotates, you're getting what? Double? You're getting at least, a boost. And you know how I know? Because I spin the stator, and when I have these hooked up, there's lights on them, right? So when I spin the stator, the lights barely light up. But when I spin the rotor in counter rotation with the stator, these light up brighter. So I know that one creates energy, but not as much as the other, or both of them combined. And it doesn't matter either way because all of it's going right back into it anyway. There's no capacitor saving, no dumping, no anything like that. That's going to go on over here. There's see, with just a bridge rectifier on there, this thing becomes extremely balanced. It's very well balanced. There's 120 on the bottom, which is 3. There's this plate, which is a complete circle, which makes it even on all 3 sides. And then this bridge rectifier weighs like half a gram, if not less. And so it's like, boom, there you go. You're balanced, very balanced. See, I think there's something not right though. I think we can do without that plate now, because now we got the bridge rectifier, and not this big clunky thing. We don't need that plate to house anything anymore. We don't need it. But there's going to be all these clips unless I figure out how to solder tonight. And there's going to be all these clips tomorrow still. But there won't be anywhere to put them, really. But I think we can manage. I think I can, I don't know. We'll see. For sure. I would like to get it to the point where when I spin it up real hard, it doesn't have to rock everything. If we get rid of the plate, we'll only have 2 bearings on there instead of 3. There's 3 bearings on there now, so that's definitely not good. That's a lot more friction. Oh yeah. But right now, all the energy that I'm gathering from this system is going back into its motion. And you're typically not supposed to be able to do that because it will lens. It'll lens even if you don't have the power on, if you got the right coil in front of there. Or what, it'll break itself. I tried putting the pickup coils on the front so you get most of the energy generation, and then the drive coils would hit from behind and maybe push it, maybe have enough, field to move it along. Wouldn't even like spin for 3 seconds, man. It just stopped. And what I think it might have been is that there was a blown reed switch. Now that makes sense, don't you think? So when the energy got high from me spinning it really hard, it was closed, permanently closed circuit, which instantly slowed it down. Because if it's not switching, then it's going to slow down. With that in mind, I think I'm going to try again, but with 32 gauge coils instead of 30 gauge. I'm going to put the drive coils behind and the pickup coils in the front. Or I'm going to stagger them. I'm not sure. Maybe I'll do 2 to 1. 2 to 1. I don't know. We'll see. I'm going to have to test it all out like as I'm doing it, because you don't want to put this whole thing together and then be totally wrong and then have to take it all apart to that point. You want to test it at that point and find out whether or not you're right or wrong then. And I think it's going to slow everything down to change it up. Maybe even the gauges. I'm not sure about that one though. That's why I'm willing to do it. But I'm willing to wager that if I put the pickup coils in the front, and well, I don't know, if the reed switch thing is a thing, then this should work and be awesome, like literally totally awesome. But you know, if it is a thing, then it's going to slow right down. It's going to slow down immediately, pretty much. Like if it is a broken reed switch, it'll stall out right away. That's gonna be fun. And then like well, I mean, if it works like this, it's gonna be awesome, man. It's gonna have energy. It's gonna have but I don't know. I really don't know what's gonna happen. Oh no, not perpetual. It is self-run though, but it'll stop. It's not perpetual. It's not a no. No, this thing is, it is, but all the energy that is being generated is put back into its motion, so it's not being stored anywhere. There's no capacitors in here. There's no batteries in here. The only piece of equipment that I have are just 3 pieces, 4 pieces, 5 pieces, okay? There's 2 rectifier diodes. There's a bridge rectifier, and there's 2 reed switches, and that's it. And I think the simpler the better when you're doing something like this. And the purpose of this is to see if I can make it spin for, let's see, 10 minutes. It is a self-running, counter-rotating DC. There's no motor per se, really. There's no power, but it's a counter-rotating self-runner. You can see it cogging right now, so you can't tell me that it hasn't been doing that the whole time. You can't. But usually when it cogs, it's done for the day. There's no purpose to it. A purpose would be, you know, like it's gonna like fly somebody over to the hospital or something like that. It's not gonna do anything like that. It's made out of plastic and neodymium magnets. There's coils on there too, so copper. And then there's, like I said, those 5 components, and that's it. Now everything's maglev, so it could very easily be moving this much without anything going on. For sure. I think it could easily do that. But I know something's going on there because I made measurements, you know, about 1.5 volts of power comes through when you spin the stator alone. And the only reason that it doesn't get more than 1.5 volts is because it's got a reed switch attached to the same line that I'm drawing from with this. So every time that the reed switch passes a magnet, you get a drop in voltage on the meter. It usually stays up right around 1 volt. So there. It's real. There's no like see, I don't even understand what the word purpose. This doesn't have like a quote unquote purpose. Yeah, it's not gonna like mow the grass. It's not gonna, you know, wear a collar. You know, it's not gonna lift a sledgehammer and then slam it down really hard. It's not gonna do that. You know, there's tons of things that this doesn't do, but I mean, like, it moves. And it moves on its own power for however long it's going to move for. And I think that's great. Yeah, it's taught me a lot about magnetism and electronics. How to, you know, this building it this way has pissed a lot of people off. Because they're all like, well, where's how do you get the readings and yada yada yada, and it's like, well, I don't know, you can't really do that. You need wireless measurements, measuring tools. You need wireless capabilities. Yes, sir. Stop. The top slows down a lot faster than the bottom for I think two main reasons. There's 3 bearings on the top. And you hear that grinding when I push it down like that? That is, I can see it like it's stuck on the pole. That's not good. So when I put the bridge rectifier on the rotor underneath this plate and remove the black thing, I think 2 things will happen. It will become more balanced and it'll have less friction. But I got to find a place for all those clips if I don't learn how to solder tonight. So, this is what you do when the top slows down. You spin it again. Because I don't want to have to, like, you know, explain to people that this, well, actually, maybe I should. This is not perpetual motion. Okay, when I say self-runner, when anybody says self-runner, they are not saying that it runs forever. You know, so when somebody, like, if you're going to, like, chastise somebody for this, you should really make sure that they have it said and stated, this will run forever. You should really make sure you know what you're talking about before you do something like that. This is not perpetual motion. think that maglev, that donut under there, is a little off. It's a little crooked. I don't know how I'm going to get that straight. I don't know how, I mean, it's really, really close right now, but it's not straight. Maybe I have to re-engineer it to have a little place for it to rest in. Yeah. See, this is a bowl. This purple thing is a bowl. It's a bowl, and there's already 3 clips inside of it. So I got to get all these clips, and I got to get it inside the bowl, and then maybe put a little cap on that, like a tiny one. But I think this magnet has to be re-centered. It has to be centered properly. I would love to get readings off of this thing, but I still don't understand like how I can do that. When it's functioning, both of these things are moving. Okay, and there's only one way you're getting a reading off of that, and it's if the middle's not moving and the stator is moving, or the outer ring is moving. Then you're going to get some readings. But when it's all fully on, like this, you're not going to get readings unless it's wireless, some kind of wireless technology that you're getting the readings with. Now you can put a piece of copper down here and have a brush hanging down. Immediately, it's not a good idea. I mean, you could do that, but it's not a good idea. I mean, if you have true a respect for what it is and what it does, that's not a good idea. A lot of people don't. A lot of people don't have any respect for it. They're like, you're going to have to stop one of those so that you can get a reading. I'm like, there's no power in it to begin with, so I don't think I need to do that. Yes, sir. I think that's great. Sure, bruh. Yes. The brushes would definitely allow for some sort of contact reading. Yes, yes. Now, what you'd be looking for in the Tesla coil field is like the part that this would fill in, like the negative of the photograph. And you use that kind of idea to find out what's going on here. But I think it's just a very low burst of energy. Every time the reed switch hits, it does what it's supposed to do. It's just, it dwindles every turn, every magnet actually. Now it gets to this zone where it like goes at the same speed for a good 5 minutes or so. That's the spot right there. That's nothing goes for like this goes for 5 minutes without slowing down. It just doesn't happen. I guess the maglev does mysterious things. I guess it totally could happen. But I don't know, like this particular build has been the most productive continual motion that I've gotten out of the self-runner series. So basically, this is the best one yet out of this entire like idea And I've gone down quite a rabbit hole here. It's awesome though. I wouldn't do it any other way. Uh, and I don't read, man. I'm not reading a lick of anything, dude. Please don't write me an essay and expect me to learn from it. Not going to happen. I gotten all my education in regards to electronics from myself and YouTube community. Like I take what they have told me and what their suggestions are, and then I put my own twist on it. You know, I put my spin on it. And right now it's post-apocalyptic, basically. See, it's cogging. It's moving. It's gonna stop soon. But yeah, that's awesome. That's real. That's motion right there. That's power. A little bit. So cool. I might actually, after the presentation, swap those coils and see what happens. Yeah. All right. So I'm going to show everybody what's on here real quick. All right. So you got your coils. There's 6 coils on this thing. You got 3 pickup coils and you got 3 drive coils. The drive coils are hooked in series. All the 20 gauge is hooked together and hooked to a reed switch. And all the 28 gauge is hooked together and hooked to a reed switch. Now those 2 gauges are hooked to a bridge rectifier up here, right here. And the pickup coils are hooked to it as well. So all that energy gets transformed, interchanged. Yeah, we need to get rid of this thing, man. That's stiff. That is like stiff on there. That's not good. But it moves really good. I mean, it's ceramic bearings, so. All right, that was a weak spin. So this is all north magnets facing in. All these magnets on the stator, north in. Now we got the rectifier diodes. They're facing this way, so I'm going to spin the rotor that way. Now the fact that this is generating right now should, people that know about this, are like, you're going to get a lens effect from generating, right? Well, I got the coils proxied to a point where they're an inch and a half away, and then I tested them to see if they were generating any electricity, and they generate about 1.5 volts. With the stator going this fast, they generate about 1.5 volts. And that's because they're so far away. And I think that if I move them or stagger them, get one of them closer to the magnets, then it's either going to lens to death or we're going to get a boost of, electricity. And I think the reason I have them this way is because it's going to lens to death. But I'd love to see what happens. I might wait till Friday to change that up, because I don't want to break anything. But I'm having new stuff come on Friday. I'm getting a few more reed switches, getting a few more transistors. Should be good. I got some ABS filament, and I'm gonna print another one of these. Try to get it straight this time, you know, because this is dumb and being so wobbly. But I mean, I think the wobble is actually good for some reason. Yeah, I was like, before when I had this hooked up, I could have put a battery on this and you could have had it have some power, but I needed to change that because it wasn't running like this. It was not running like this. But I can hook the battery right up to that thing, and I might even be able to do it with this, but I doubt it. But hook the battery right up to that, and just, yeah, wow. Oh yeah, I had the resistors on there. Where did I put them? Oh, yeah, I had these on the lines, on the 28 and the 20 line, and yeah, it would slow down a lot faster than it's slowing down now. And that's how I know that there's power there waiting to be controlled. Bye now. See you later. Thank you for coming in. Well, you are, though. You just recharge your batteries every night. Okay, when you say that, I want to know exactly what you're saying. Hello, hello. All right, I'm going to bust out my permanent magnet rotor now. Hold on. Oh my God, I think that's 3 north, 1 south. That's awesome. All right. I wish I could get it to spin, longer period of time. That's what I'm working on. But I think the fact that it spins like that at all is amazing because there's so much traction going on in here that it's unreal. It's look at that. So much power in here. All right, so I'm going to couple it real quick. All right, so it'll spin like that, and it's 4 magnets in the middle on 6 magnets on the outside, so that's why it's doing that. But it'll spin like that until this stops. Get it to counter spin. That's awesome. I mean, now I think there's 2 things that I can do to make this better. One is find the correct ratio from inner to outer, and 2, have it so when the magnets pass each other, there's no direct pole interaction. You don't want direct pole interaction. You want it to hit off to the side or like this. You don't want it to hit like that because it's going to slow everything down. This is designed, this is pole to pole. This is why it's not moving as fast as it can, because it's going pole to pole. There's lots of friction here. I'm not sure exactly. I know that it's a thing. I'm not sure exactly what the outcome is of the thing. So based on what I know from what I've seen, okay, that seemed like a gunky bearing right there. You see how that just stopped like that? That doesn't seem natural. Totally not cool. That means, I need to get new and better stuff. I can't, these bearings are really bad. They're really bad. But then again, they are years old and probably, I don't know. They have flanges on them though, so they're designed to hang about above. I'm going to lower it now. You guys probably can't see it from there, so I'll bring you over here. Whew. Hold on, I got to put this in here. So that is, there's 3 north on the rotor right now, and 1 south. Oh no, wait a minute. There's 3 south on the rotor and 1 north. What I'm saying is there's 3 attracting nodes here and 1 repelling. So you can see it. It's jerking me. It's jerking my hand like that. Alright. So I push it down. We'll see if being like under the magnets helps at all. So although I have done pretty much all these experiments, it's still preliminary. Like I'm still, I don't remember everything I did. I'm not writing stuff down. I'm just playing around right now, and I'm remembering, you know, some key points considering I'm doing it freshly. So I'm even wondering, like, if having 4 attraction points would work. But I like to have, you know, I thought that having the repulsion worked pretty good so far anyway. Yeah, so typically these move for, at this size, I should say, they move for about a minute. You know, when they get going pretty good, they go for about a minute. Now if you build a small one, a little tiny one, that one can go for hours, if not days. Just like this. Like have the, but I don't know if you can get reed switches. I don't know, this is a permanent magnet rotor. Jeez. Well, that's what you get for playing with both at the same time, pretty much. So when I here, you would have the magnets angle so that they do not hit pole on pole. You don't want the poles to match up when when the magnets cross each other. You want the poles to be off center in the magnet and more kind of on the edge of the field. So like you would turn them like that. But then you would have a definite way you would have to spin this to make it work, kind of. Right now you can spin it any way you want because you're pole to pole and it'll line up. But yeah, I don't know, that it doesn't last very long, so and when my batteries get charged up, I'll get some M.P.H power on the wheel. I want to make another rotor. I want to make the rotor that goes with this. I want to make another stator that'll be much, much better than that one. It's great, but I mean, it is wobbly, it's falling apart, lots of different things. So I think that I'm going to make a maglev with incorporating the shaft into the rotor build. So I'm going to make the rotor really tight, maybe 4 magnets or 5 magnets, and then I'm gonna have it be connected to the shaft. And I'm gonna use like a tip. Some people would use like a ball bearing or a BB, something like that, a tip. And I would have my magnetic shaft track to the magnet above and only have that ball bearing be the point of contact. So it'll spin very nice, or it could be plastic, it could be a plastic tip, and then just have it be real kind of like smooth. Not necessarily a point, but and then have one on the bottom as well that will attract or keep it all in the center. Maybe have one that's stronger on the top, just so it's dangling instead of erecting itself from the ground. Dangling from above is what you want. And that should and do it like this. Make one of these. I don't know, man. That's an engineering challenge right there. I'm not an engineer, but that sounds like a fun way to do it. Heck yeah. So the components are two rectifier diodes, two reed switches, and two, no, there's one bridge rectifier with the blue spade connectors on the top. And then all the coils there are connected in series, and that's why there's so many clips. Because there's let's see, 2 connections per drive coil. Yeah. All right. So when I let go of you guys tonight, I'm going to flip flop maybe the 30 gauge coil like one at a time and switch them. See if we won't lunge to death. Because if it was a busted reed switch, that would be awesome. I would just say, even though that sucks, that would be awesome because that would mean that this could still do what I want it to do. It only runs like this because of that incident. So I have put all the pickup coils behind the drive coils when I could maybe be doing it the other way. I don't know. I don't think so, though. I think lens is definitely going to be more of a factor when the generators are up next to the magnets. And I think that's awesome that it will go like that for what I put into it. That's amazing. But by Friday, it's going to be a different story. There'll probably be power. There might be another rotor. Right now, it's just me. I'm passing the time, disclosing my ideas to you as we pass the time. Uh, and I'm letting this thing spin while we kind of wait for the power to get here. I need more transistors. So basically the purpose of this is to pass the time. No pun intended. Sorry, buddy. All right. So, indeed, thank you. I'm wondering how long it will keep spinning for. I just nudged it. So, and you know why none of the other ones ever worked? Is because you didn't have both of them and you didn't have a counter rotation. That's why it didn't work. And if your objective was to make it spin forever, that's your fault and not mine. But if I'm giving anybody, ideas on what they can do to make theirs spin forever, awesome. Cool, man. Mm. Yeah, I don't know, man. I am just passing the time with this, and like I said, I'm letting you guys in on what I'm gonna be doing, and maybe you guys will come see me on Friday, and I'll have some power hooked up in here. I don't want it to go too fast, so I'm probably gonna leave the reed switches as a switch for my first iteration. And then we'll move on to transistors from there. But yeah, I can run it on a 12-volt battery with what's going on here, easy as pie. So I'm thinking here, there might be a way for me to hook it up. There is a way for me to hook it up using what's here now. I can hook up a battery if you guys want to see that. I don't know if it'll work though. I need to get the resistors back in there though. And with the reed switches, it will not be going fast. It will just definitely be going. All right. I'm gonna put this back up on the tripod so that I can like not aim you guys at the wall or anything. I mean, I kind of want to not have to spin it myself, you know? All right, I need to get the A. This one. This might be interesting. I tried putting 36 volts into it and I must have had a damaged battery because that didn't go well. Nope, I think I'm doing this wrong. Try that again. Hmm. Yeah, this might not, well, I mean, this is what we gotta do. I don't have an extra connector. Let's try. Man, what the hell? Sometimes these things don't connect. Hmm. Hmm. This is the first time I ever tried to do this, so I hope I did it right. I guess I'm gonna put it back in. I mean, just watching them both. Yeah, just watching them both go like that differently. That's a little better than the other one we just did. Wow. Yes, these reed switches are low frequency. Yeah, they might be broken too. I don't know. I think they're working. Now this is a series connection on the drive, so there's 3 coils hooked together on the drive. So I think it's working rather well, considering the power cost is so it's cheap because you got a 28 gauge. That's going to take no amps. You want voltage for a line like that. Amps are going to burn it up. You don't want that. You know what? I think that the drive coils are still hooked up. They're not like. All right. Now, see, I think my rectifier diodes in the direction the reed switch is going totally in conflict with one another. It's good to know that. Look at that. That's more motion than we've seen all night. Nice, smooth pace, man. That's definitely working. But I might just go straight to the transistor. I think the reed switches I have coming are a little bigger. All right, so we're going to take the diodes out for now. That might be a little tight. Yep, that was too tight. I'm gonna have to get a smaller resistor. So hopefully it's lying right here on the top. And there it is, yay. All right. So these are 220s, and these are probably going to be just fine. Okay, right. All right, now this goes into here. Come on. Come on, man. this. This is why I hate working with these clips and thin gauges, because it's just not really fun. Bingo. All right. Now, 20 gauge. Yeah, the reed switches, when they arc, they break. So I'm not looking for an arc. I'm just looking for some continual motion here. I'm gonna get bigger reed switches. I'll be able to do more. But there it is. Take those diodes out, and it should keep moving. Get this off. Mm. Now this here rotor, this one right here, is what I'm working with kind of right now. It's got peg room for one coil on all pegs. It's got 8 pegs. So you would put the drive coil and the pickup coil would be the same distance from the rotor. There's the difference with this one. And I'd probably run that one parallel, maybe. All right, we got it. I don't know, what'd that take? 20 minutes? Way too long. What? No, you don't need bigger mints, dude. Maybe if you're working industrial. Yeah, no, no. No, 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 no. You think I knew you guys were all... Well, let me see what you're saying. God dang. Same old BS, man. Sorry. So I don't think this battery is working right. I think I hooked it up. All right, well, peace out, everybody. Have a good night. It's starting to get wild. People are coming out, saying stuff. I'm going to go now. Bye.